All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing the optimization module. Let's have a look at what we went over tonight. Now, last night we left off here. Now, the takeaway here is that it's not always going to be the case when we run our hill climate algorithm that we are always going to find the optimal solution. There are things that can go wrong, and other problems that we might imagine just by taking a look at our state space landscape or these various different plateaus. Something like this flat local maximum below, where all four of the even states each have the same exact value. And so, in the case of the algorithm we showed before, none of the neighbors are better. So we might just get stuck at this flat local maximum. And even if we all allowed ourselves to move to another neighbor, it won't be clear which neighbor we will ultimately move to. We might get stuck here as well. Now this here is what we call a flat local maximum. Let me give you a better look of it. We're talking about these four states here. You see they're all four exactly the same. So if we tried to move, let's say we were here at this state and we tried to move either left or right, it wouldn't make a difference because it's the same exact value. So we wouldn't make a difference in our state. So we probably would get stuck there. That's what we're saying. And then it's the same for the minimum. It's going to be called a shoulder. Now the shoulder is slightly different because we do have different options we can make. Like say if we were here, we can always go lower, and if we were here, we could always go higher. So the shoulder is not exactly the same, but it's just called a shoulder because it's the shoulder of the algorithm. But that's what we did tonight. We went over those two concepts and we dived pretty deep. Did a lot of note taking. Then we did do a new graph here for a hill climbing variance. These are our variants: steepest ascent. We choose the highest valued neighbor. Stochastic, we choose randomly from higher valued neighbors. And first choice, we choose the first higher valued neighbor. And again, that's just a few of the concepts we went over tonight. We're going to keep moving forward and keep getting this thing down pat. You stay tuned and I'll keep on giving you knowledge. This is the Python Poppy. You guys stay Gucci.